In this lesson, I'll talk about how Android applications can define and use permissions to control access to important data, resources, and operations. First, I'll talk about Android's permissions architecture. After that, I'll explain how you can define and use application-level permissions, and then I'll finish up by talking about component-specific permissions and permissions-related APIs. Android uses permissions to protect resources, data, and operations. And applications can also define and enforce their own permissions to limit access to their resources, things like user information. For example, to restrict who can access an application's database. To cost-sensitive APIs. For example, to restrict which components can invoke costly operations, such as sending SMS or MMS messages. And to system resources. For example, to limit which components can use the device's camera to take pictures or record videos. So, in Android, permissions are represented as strings, and applications include these permission strings in the Android manifest XML file. And they can do this to declare the permissions that they use themselves and to declare the permissions that they require of other components that want to use them. Let's look at each of these uses of permissions one at a time. So first, when an application needs to use a permission, it specifies that permission by putting a uses permission tag in its Android manifest.xml file. And when that application is installed on a device, the user will have to accept that permission. Otherwise, errors or access failures will occur. Now here, I'm showing a snippet of the Android manifest.xml file for a hypothetical application. Now, as you can see, this application needs permission to access the device's camera, permission to open a network socket to access the internet, and permission to access precise location information coming, for example, from a GPS provider. Now, take a look at this documentation for a list of Android's built-in permissions. Now, you probably remember the Map Location from Contacts application from earlier lessons. That application allows the user to select a contact from the Contacts application and then to display a map centered on that contact's postal address. So here's the application in action. Now I'll launch the Map Location from Contacts application. Now I see a button that will allow me to select a contact. When I click on that button, the Contacts application shows me my contacts and allows me to select one of them. Once I do that, that contact's postal address and other information is passed to Google Maps, which then displays a map centered on the postal address. But as I've said a few times now, my contact list is private information. Android doesn't allow just any application on my device to have access to that list of contacts. So, how did Map Location from Contacts get access to it? That's right, the application must have declared that it uses the appropriate permission. And where should we look to confirm that? Again, that's right, we should look in the Android manifest.xml file. Let's do that now. So here I've opened up the Map Location from Contacts application in my IDE. Now I'll open up the Android manifest.xml file, and we'll take a look inside. As you can see, there's a uses permission tag that declares that this application uses the built-in read_contacts permission. In addition to declaring the permissions they use, Android applications can also define and enforce their own permissions. Now suppose that you've written an application that performs some privileged or dangerous operation. You might not want just any application to be able to invoke yours. So Android lets you define and enforce your own application-specific permission. And that means that other applications must be granted your permission, or Android will not allow them to use your application. Let's look at this in more detail with a simple example. So here's a simple application called Permission Example Boom. Now we're going to pretend that it performs some kind of dangerous action. In real life, that might be something like formatting your external memory card. Now let's take a look at this application in action. Now I'll launch the Permission Example Boom application. And boom goes the dynamite. Now, since this operation is clearly dangerous, we don't want just anyone to be able to start this application. So we're going to define and enforce our own application-specific permission. Now let's open up the Android manifest.xml file to see how that's done. So here's the Permission Example Boom application. Now I'll open up the Android manifest.xml file and we'll take a look inside. Here you can see a permissions tag that defines a new permission. The permission's name is course.examples.permissionexample.boom_perm. In this example, the permission tag includes two other attributes, a label and a description, which can be shown to the user when they are installing the application. The values for these strings are in the strings.xml file. Now if we scroll down a bit, you can see that this application also includes this permission as an attribute of the application tag. And because of this, Android will make sure that components that try to start this application have already been granted the boom_perm permission. Now since the Permission Example Boom application now requires the boom_permission, any other application that wants to use it will first have to acquire that permission. So let's see what happens if an application without the proper permissions tries to start Permission Example Boom. So here I'm showing my device, and I've installed a second application on the device called Permission Example Boom User. And when I launch this application, it presents a single button labeled Detonate. And if I press this button, the Boom User application will start up the Boom application, which, as I just showed, requires the boom_perm permission. The Boom User application, however, does not have that permission, so Android should prevent it from starting up the Boom application. Now before I press the Detonate button, I'll also point out that I've opened the IDE and that it's showing log output from the running device. Okay, so now I'll press the Detonate button. And as expected, something bad has happened. The device is showing an error dialog telling the user that the Boom application has stopped. And if we also go and look at the log output, we can get more information as to the cause of this problem. And as you can see in the log, Android has thrown a security exception saying that Boom User requires the boom_permission. So let's fix that problem. Now if Boom User wants to use the Boom application, then it has to first declare that it uses the boom_permission. To do that, it will put a uses permission tag in the Android manifest.xml file. Let's see that in the code. So here's the Boom User application code. And now I'll open up its Android manifest.xml file. And here you can see the uses permission tag with a name attribute whose value is the same as the permission that's defined by Permission Example Boom. Okay, so now that we've added the uses permission tag, I've reinstalled the Permission Boom User application on my device. So let me go to the home screen and launch it. Now there's the Detonate button again. And so now I'll press it, and boom goes the dynamite as expected. So far, all the permissions I've shown you have applied to the entire application. Android also allows you to set permissions for individual components. And these settings will take precedence over any application level permissions. Now let's take a look at some of these component permissions. Activity permissions restrict which components can start the associated activity. These permissions are checked within the execution of methods such as start activity and start activity for result, which, as you know, are called when one activity tries to start another one. And if the required permission is missing, then Android will throw a security exception. In fact, that's exactly what happened in the permissions boom user example that we just went over a few seconds ago. Service permissions restrict which components can start or bind to an associated service. Now, we haven't talked about services much yet, so I'll just mention that these permissions are checked when requests are made to start, stop, or connect to services using methods such as context.startService, context.stopService, or context.bindService. And just as with activities, Android will throw a security exception if required permissions are missing. Broadcast receiver permissions restrict which components can send and receive broadcasts. Now again, we haven't talked about broadcast receivers very much yet, so at this point I'll just say that these permissions are checked in a variety of different ways at a variety of different times. And we'll talk more about this in later lessons when we discuss broadcast receivers in more detail. Content provider permissions restrict which components can read and write the data contained in a content provider. And again, we'll talk more about this in later lessons when we discuss content providers in more detail.